Welcome to All This Math. This is Professor Parker, and today we're going to talk about simplifying radicals. All right, so let's look at number one. This reads the square root of 25, or some people might say the root of 25. Now this symbol right here is called a radical sign. The symbol that kind of looks like a long division sign, right? But it's got this little tail right here. This is called a radical sign. Now, the number under the radical sign is called, let me give you some vocabulary. It's called a radicand. All right, so you got a radicand. Radicand. That's the number underneath of the radical sign. All right, now, the number that's inside this part right here, this little V part, is called the index. Now, what you should be saying right now is, Professor Parker, what are you talking about? There's no number written right there. And I'm like, yeah, I know. Sometimes there will be a number actually written right there, but sometimes that number will be invisible, right? If there's ever no number written right there, then that means that the index is 2, which makes this a square root symbol. If there was a 3 written here, for example, this situation, this would be the third root of 27. Or also called the cube root of 27. All right? But when there's no number written here, or no index written there, then we understand that that means that there is an invisible 2 right there, which means that we are looking for the square root of this number. Now, what does the square root of that number mean? It means we are looking for a whole number that can be multiplied by itself that will equal the radicand. That's what we're looking for. Now, that brings us to the next term. Perfect square. Now, a perfect square is a number that you can arrive at by multiplying a whole number by itself. Now, and then that number that you would multiply by itself is called the square root, which would be the answer to this problem, or the answer to each of these problems. We're looking for the square root of each of these problems, meaning we're looking for the number that can be multiplied by itself to equal this number underneath of the radical sign. Now, every number does not have a whole number square root. Only perfect squares, like 25, have a whole number square root. All right? Meaning, the number 5 is the square root of 25. 5 is a whole number. And 5 times 5 is equal to 25. Right? But if you have a number that requires you to multiply, like let's say 5.1 times 5.1, that number that you end up with, that product, would not be a perfect square. Because perfect squares have factors that multiply by themselves that have to be whole numbers. All right? So, as I said, the answer to number one, the square root of 25, is 5. Now, it's just plain 5. Some people make this very popular mistake. They keep the radical sign, and they would say that this is equal to the square root of 5. It's not equal to the square root of 5. It's equal to just plain 5. No radical sign, just plain 5. And remember, what this is asking is what number multiplied times itself will equal this number. Now, if you have a composition notebook, good old school, old-fashioned composition notebook with the, the marble cover in the back, you can go to the back cover of that book, or the back page, the cardboard part, right? Go to the multiplication table, the 12 by 12 multiplication table. If you look at that chart, you start at the upper left corner and you go down diagonal to the bottom right corner. All of those numbers are perfect squares. All right? You also should memorize all your perfect squares, as many as you can. All right? So the square root of 25 is equal to 5. And that's easier to do than a lot of problems because that doesn't really require any simplifying, because that's just a perfect square. I just wanted to put that out there just to give you like a baseline, just to show you, okay, this is what we're doing. Like sometimes you'll have problems like this, but then sometimes you'll have problems like numbers 2 through 4, which are a little different. They're a little bit different. They require a little more thinking and a little more work, a little more understanding of number sense. So we finished with number one. Number one is 5. Again, because 5 times 5 is equal to 25. So the square root of 25 is 5. All right. Now, number 2, we're looking for the square root. See, there's no number written here. So that's the second root, or the square root, of 128. The first question you ask yourself, and you should write this down, is this radicand a perfect square? Is it a perfect square? That's the first question you should ask yourself. And I just happen to know from having familiarity with these numbers that 128 is not a perfect square. Now, this is something else that I recommend you do. If you don't have your 12 by 12 multiplication table memorized, and you don't have the perfect squares from 1 to 144 memorized, then I suggest you write them down on your paper. So I'm going to write them down right here. Now, where do the perfect squares come from? You start with integers, all right? Integers, factors, 1 through 12, right? Because that's what you have in the multiplication table in the back of the composition notebook. Let's just start with those. So let's say 1 times 1. That's 1. 2 times 2. 4. 3 times 3. 9. 4 times 4. 16. 5 times 5. 25, like we just had right here. 6 times 6. 36. 7 times 7. 49. 8 times 8. 64. 9 times 9. 81. 10 times 10. 100. 11 times 11. 121. 12 times 12. 144. Now, I know all these, right? I don't know all these because I'm smarter than anybody. I know all these because I've used that multiplication table literally thousands of times. It just comes from repetition, right? That's why I know it. It wasn't no math gene. I wasn't born knowing that, 40 years ago. I wasn't. I've just practiced. Just like successful athletes, they practice, right? We have to apply the same type of tenacity and the same type of attention to our math work, and we'll be just as successful. All right, so look, you want to make a list. If you don't have these numbers memorized, you want to make a list. Do yourself a favor. Write things down or use charts, because if you have to think about what the numbers are, that leads to more confusion in many cases. So now we have our list of perfect squares. Now, the first question is this radicand a perfect square? So the radicand is 128. Is 128 on this list? It is not. Now, these are not all the perfect squares in the universe, but here's the thing. If I'm questioning 128 whether it's a perfect square, if I know that 121 is a perfect square and 144 is a perfect square, 128 would be in between 121 and 44. It's not on the list. It's not on the list, because if 11 times 11, because remember what a perfect square is. A perfect square is a number that has a factor that can be multiplied by itself, a whole number factor that can be multiplied by itself to equal that number. So that means if we have 11 times 11, which gives me 121, and 12 times 12, which gives me 144, it ain't no other whole number in between 11 and 12. It doesn't exist. All you got is decimals in between 11 and 12. Decimals and fractions in between 11 and 12. So there's no way that 128 could be a perfect square, because 128 would be in between 121 and 144. So that's why we know 128 is not a perfect square. All right, so that's the answer to our first question for number 2. Now, the second question you ask, if it's not a perfect square, because of course, if the answer to this is yes, it is a perfect square, then we just rock out and get the answer like we did in number 1. The square root of 25. Okay, well, what is it? What whole number times itself equals 25? We know, okay, 5 times 5. Now, let's say you wasn't that familiar with the multiplication table or the perfect squares. All you would do is just list out all the factors of 25. You would say, okay, 1 times 21 and 25, and 5 times 5. Those are the only 2 ways you can multiply any whole numbers to equal 25. And 25 times 1, those are not the same numbers. 25 and 1 are different numbers, but 5 and 5 are the same number. So therefore, 5 will be your answer. Now, when we get down to 128, the answer to our first question is no. So therefore, we got to go to another question. And this involves number sense and understanding factors. All right? Question 2 is, what is the biggest, I'm going to call it PS. That stands for perfect square. PS, perfect square. PS, perfect square. What is the biggest perfect square factor of this number? All right, or of this radicand. Perfect square factor of this radicand or number. So let's think. Now we got to think about it. Now this is why it's important to have our list of perfect squares written down, right? Unless you just know them off the top of your head. If you know them off the top of your head, cool. But if you don't, do yourself a favor. Write down the list of numbers, all right? Or have the list of numbers written down. Or have a multiplication table that you're looking right at in front of you, sitting on your table in front of you while you're doing your work, while you're answering examples of simplifying radicals. So 128. Now, here's the thing. You start at the bottom of the list, or the smallest number in the list, rather. 1. 1 is a factor of everything. But 1 does not help us in this situation, right? When we're doing this, 1 does not help us. So we want to cross 1 off the list. We don't want to deal with 1. Now, we want to pick the biggest perfect square factor of the number 128. Now, 4 is a factor of 128. How do I know that? Because if you do the division, if you do 128 divided by 4, that will be 25 plus 7, that equals 32. So 32 times 4 would give you 128. So I could break that down into 32 times 4. But I also happen to know, just because I know this, because I've been doing examples like this for a long time, I know that 4 is not the biggest perfect square factor of 128. Now, if I don't pick the biggest, let's say I pick 4. If I don't pick the biggest, I'm going to have more work to do. I'm going to keep having to do the step over and over again. I only want to do this step that I'm about to show you one time. So that's why I'm going to pick the biggest perfect square factor. So I keep going through the list. All right. So I'm not going to use 4. 9 is not a perfect square. How do I know? 128 divided by 9 does not equal a whole number. 16. 16 actually works. 128 divided by 16 is, what is it? It's 8. It's 8. But I also know that 16 is not the biggest perfect square. It's not. Not the biggest perfect square factor. It's not. All right? 25 is not going to work. I know that. 9 didn't work. 36 won't work. 49 won't work. What about 64? Will 64 divide into 128? Yes, it will. 128 divided by 64 is equal to 2. 128 divided by 64 is equal to 2. So that means 64 divides evenly into 128. All right? So 128 divided by 64 is equal to 2. Now that I know this, what do I do with this information? Why do I care what the biggest perfect square factor is? Because watch this. This is what I'm going to do. I'm going to change this 128 into 64 times 2. Now, why did I do that? Because now I can simplify this. And that's what we're doing. We're simplifying radicals. I can simplify this now because 64 is a perfect square. It's from the perfect square list. So 64 basically can come out of the radical sign because it's a perfect square. But when it comes out, it's not going to come out as 64. You take the square root of 64. Just like we took the square root of 25 and it was equal to 5. When you take the square root of 64, you get 8. Because 8 times 8 equals 64. Again, a whole number multiplied by itself has to equal that number in order for that number to be a perfect square. Now, you should be wondering, well, what about the 2? The 2 can't come out. It can't come out. It's just like when you're little, you want to go outside and play, and your mom and your dad tell you got to go clean your room. You can't go outside until you clean your room. Your room got to be perfect. Your room got to be spotless. The 64 can come out because its room is perfect. It can come out. The 2, its room is still messy. You got to stay in the house. Think of the radical sign as a house. 64 can come out. It is perfect. The room is clean. The room is perfect. You can come out. The 2, you ain't perfect. You can't come out. You got to clean your room. And how do you know 2 is not a perfect square? It's not on the list. It's not on the list. 2 is in between 1 and 4. If 1 times 1 is 1 and 2 times 2 is 4, there's no number between 1 and 2. There's no whole number between 1 and 2 that you can multiply by itself to give you 2. So this is what our answer should look like. Once the 8 comes out, you simply write the 8 next to the radical sign. Then you write the radical sign 2. Because remember, the 2 is still in there. The 2 don't come out. 64 comes out and turns into an 8. So you have 8 root 2. That is your final answer. And I know it's my final answer because I can't take the square root of 2, and I also can't factor 2 out where it has a perfect square factor. So that's how I know this is the final answer. So I'm going to draw my box around here. That's that. All right. Now, on to number 3, square root of 300. Go back to our two questions. Question number 1, is this radicand a perfect square? Now, I just happen to know that 300 is not a perfect square. All right. Because there's no whole number that I can multiply by itself to equal 300. I know that 17 times 17 is equal to 289. And 18 times 18 is 324, I want to say. Yeah, I'm pretty sure that that's correct. I'm like 99% sure. Now, again, I just said that off the dome, off the top of the head. Now, does that mean that I'm smarter than anybody? No. It just means that I've been doing this math over and over again, thousands of times, through memorization and repetition. That's why I know this. That's the only reason. If I can do this, if I can know this from repetition, you can know this from repetition. All right? So, if I know that 17 times 17 is 289 and 18 times 18 is 324, 300 is in between 289 and 324. But there's no whole numbers in between 17 and 18. When you learn how to count, you learn 17, then 18. There's no whole number in between 17 and 18. There are decimals and fractions, like 17.5, 17.1, 17 and 2/3. Those are not whole numbers, though. Remember, when we deal with perfect squares, we're looking for a whole number that can be multiplied by itself to equal that number. In this case, to equal the radicand. So, we got that out the way. Question 1 is not a perfect square. So, since the answer to question 1 is no, we go on to number 2. What is the biggest perfect square factor of this number? So, again, because we want to break 300 down into 2 numbers, 2 parts. Just like we did in number 2. We broke 128 down into 64 times 2. Why do we do that? Because then we can simplify. We can take the square root of one of those numbers, right? Not both numbers, just one of them. All right? So, 300, we go to 1. 1 we never use. 4 is not the biggest. 9, can't use. 16, not sure if 16 goes into 300. Does 16 go into 300? Let me think. I don't think so. Yeah, I'm pretty sure it don't. If you take out your calculator, do 300 divided by 16. No, it won't. It won't go, it will not, 16 will not divide into 300 evenly because 16 times 10 is 160, leaving you with 140 left over. 16 definitely does not divide into 140. So therefore, 16 is not a factor of 300. Okay, 25 is a factor, but it's not the biggest. All right, 36, not a factor. 49, not a factor. 64, not a factor. 81, not a factor. 100. Does 100 divide into 300? It definitely does. It definitely does. So we're going to change 300 into 100 times 3. Now, you might be wondering this. Does it matter what order we write the 2 numbers in? Would it make a difference if I wrote 3 times 100 instead of 100 times 3? No, it would not make a difference because of the commutative property of multiplication. The order does not matter. All right? Now, if we're dealing with a word problem involving multiplication, changing the order around will make a difference in what's actually happening if we're dealing with a word problem, a real life application. But if we're dealing with something abstract, just numbers, the order doesn't matter at all. It makes no impact. It changes nothing. All right? So now, 100 times 3. Now, 100 is a perfect square. Question for you, what is the square root of 100? The square root of 100 is 10 because 10 times 10 equals 100. A number times itself equals this number. So that makes this a perfect square, and that makes 10 the square root of 100. Not of 3, but just of 100. So we're going to take 100 out because 100 is perfect. So 100 can come out the house. And when 100 comes out the house, it doesn't come out as a 100, it comes out as 10. Because 10 times 10 is 100. So now, just like in number 2, the 64 came out as an 8 because the square root of 64 is an 8. Now, How do I know that I should be taking the square root? Because that's what this symbol means. This radical sign is like instructions. It's telling you what to do, right? So you got to look and understand the symbols in math problems. The symbols tell you what to do. So in case you're ever wondering, what am I supposed to be doing? Like, just look at the symbols. This radical sign is telling you that you need to take the square root of this number. But then when we simplify this number, we convert this number into two factors. You still need to take the square root of any number in there you can. We can't take the square root of 3 because 3 is not a perfect square. But we can take the square root of 100. So I got 10 on the outside, and 3 is still on the inside, and I'm done. So the way I read this is 10 root 3, or 10 times the square root of 3. Either way is cool. 10 root 3 or 10 times the square root of 3. All right, number 4. The square root of 18 is what I'm trying to find. Now, first question. Is this radicand a perfect square? Is 18 a perfect square? Go to your list. Is 18 on this list? No. Look where 18 will fall on this list. It would have to be between 16 and 25. But the square root of 16 is 4. Square root of 25 is 5. There's no whole number in our number system that falls between 4 and 5. And if 18 was in between 16 and 25, its square root would have to be between 4 and 5. Because 18 is between 16 and 25. That's how that works. So therefore, we know the answer to question 1 is no. It's not a perfect square. 18 is not a perfect square. So now we got to go on to the second question. Second question, what is the biggest perfect square factor of this number? What's the biggest number that is a perfect square that will divide into 18? Now you go to our list. I told you before, we never use 1 because 1 doesn't help us. 1 doesn't change anything. Now, in case you were wondering what I mean by that, let me just real quick go into that. Why does 1 not help us? Let's imagine if this happened. Let's say I used 1 as my perfect square factor. What would I change 18 to? I would change it to 1 times 18. Okay, 1 times 18. 1 is a perfect square. 1 comes out. What does it change into? It's still a 1. Because 1 times 1 is 1, right? So now I got 1 on the outside and square root of 18 on the inside. How is this any different from this? Ain't nothing gets simplified. We're supposed to be simplifying radicals. Nothing got simplified. So when I say it, or when a teacher says it, or anybody says it, we don't use 1 in this situation, in these types of problems. That's the reason why. And understanding why is important. Because when you understand why, then you start to feel more comfortable with the work that you're doing. So let's erase that. And now we know why we never use 1. All right, so we don't use 1. So 4 is not a factor of 18 because 4 can't be multiplied by another whole number to equal 18 at all anyway. What about 9? 9 is a factor of 18. And 9 is a perfect square because it's on our list, right? Memorize this list ASAP if you don't have it memorized already. 16, no, 16 is not a factor. 25 is bigger than 18, so you know that's not a factor. So 9 is what we're working with. We're working with 9. All right? Radical sign, 9 times 2. Now, 9 is the perfect square. Next question for you is, and I should ask that should be question number 3. What is the square root of that perfect square factor? Yeah, just throw that in. What is the S dot R dot square root of the PS, perfect square factor? So these are your 3 questions, actually. Yeah, this is like a living document, right? These are important notes. Question 1, question 2, question 3. So 3 magic questions that will help you to simplify radicals. All right, so at any rate, 9 is a perfect square. What is the perfect square? What is the square root of the perfect square factor? The square root. The square root of 9 is 3. 9 comes out as a 3. So 9 comes out as a 3. And I have equal sign. My 3 is outside. And my 2 is still inside. And I have 3 root 2. All right. So that's just a little introduction on how to simplify radicals. You will need to know this skill when you deal with using the quadratic formula, when you deal with, that might be in Algebra 2, maybe late in the Algebra 1 class, completing the square around the same time, same unit, or those units are usually taught close to each other. When you get into geometry and you're dealing with the area and circumference of circles, you may deal with this, or you might deal with this, in other situations where you have measurements or just using terms that are radicals or that are square roots. And you're expected to simplify your answer and find square roots, but maybe the radicand is not a perfect square. So this is definitely a skill that you need to have, right, for a lot of your mathematics courses. All right. So I hope you learned something today. Please continue. Send your questions into the All This Math DM, and your problem might make it to this board. Peace.